Hello everyone, today I'm going to talk about the coupling types and how they affect the misalignment and cooked bearing fault analysis. My name is Salah Atiyah, I'm Condition Monitoring and Reliability Specialist. The first type I'm going to talk about today is the angular misalignment. You should see elevated vibration at the running speed component 1x with the second harmonic 2x on the axial direction, and mostly in this case you will see the 1x is higher than the 2x. Also you can see 1x and 2x with lower amplitude of 3x on the radial direction. The phase measurement across the coupling will be out of phase 180 degree on the axial direction and will be in phase on the radial direction. As you can see from the plot, if you measure the phase across the coupling, it will be out of phase 180 degree on the axial, and you should be careful about the sensor orientation. The severe angular misalignment can cause 1x with harmonics similar to looseness, but with no noise floor. The second type is the parallel misalignment. You should see elevated vibration at the running speed component 1x with the second harmonic 2x on the radial direction. Mostly 2x amplitude is higher than 1x, and this is different from the angular misalignment. But you still can see 1x with 2x and 3x in the radial direction. At this case, the phase measurement across the coupling will be out of phase 180 but on radial direction, not on the axial. The misalignment caused by improper alignment or can be caused by missing thermal growth from our calculation when we do alignment job, or also can be because of outsource like pipe strain. The difference between the looseness and the severe misalignment, you can see from the top plot, you can see 1x with harmonics with some noise floor. But in the case of severe misalignment, you will see the 1x with harmonics, but there is no noise floor. Also, the coupling type really affect the misalignment. Like, you not see angular misalignment by itself or parallel alignment by itself. You see combination between both of them. And definitely the coupling type affect the misalignment vibration pattern on your spectrum. For example, if we talked about the jaw coupling, mostly you will see 1x and 3x, or 3x and 6x, and this depends on the number of jaws of the coupling. On the gear coupling, you can see high 1x with little harmonics, for little amplitude with harmonics, and you can see 1x and 2x with moderate amplitude and high amplitude 4x. On the metallic grid coupling, you can see high amplitude 1x with very minor amplitude for the harmonics, or you can see just high amplitude at the 4x. On the flexible disc type coupling, you can see minor 6x, or you can see high amplitude at the 2x and 4x. On the rubber coupling, you can see 1x and 2x, and it can be 1x higher than the 2x or the 2x higher than the 1x. The last thing is the cooked bearing. Cooked bearing is very similar to misalignment. You can see 1x, 2x, and the 3x, and you can distinguish between the cooked bearing or the misalignment. When the misalignment happens, you should see it on both the drive and the driven machine. If you measure the vibration on the drive machine, which is the motor and the drive end bearing, and on the driven machine, which is the fan at the drive end bearing of the fan or the pump or the gearbox, you should see the misalignment pattern at both of them. And if you measure the phase across the coupling to confirm the misalignment, it will be out of phase in the axial for the angular or out of phase in the radial for the parallel misalignment. At this condition, you mostly will see it in one of the bearings only, of the drive or the driven. And cooked bearing looks very similar to misalignment. You'll be seen in the spectrum as elevated vibration at the running speed 1x with the second and third harmonic. And if you measure phase on the face of the bearing itself, cooked bearing will cause twisting motion and will cause phase shift about 180 degree on the axial direction, top to bottom and left to right around the bearing face. That's all for today. I hope you liked the video. Please like, subscribe and share. And that's all. Thank you.